All right, welcome back. Now, let's talk about graphing log functions. Okay, so let's think about this for a moment. So if we look at plotting points and we want to get an idea of what this looks like, so let's take a look at this function here, y equals log base 2 of x. And so what we're saying is, okay, so if we want to write this in exponential form, right, this would be 2 to the x equals y, right? So as we stick in values of x, what happens to y, right? So, but, oh, hold on a second. I wrote that wrong. Hold on. Sorry. I'm so used to writing in terms of x. So 2, so this equation, remember, 2, the log is the exponent, right? Y is the exponent. So 2 raised to the power of y equals x. That's what I wanted. That makes more sense. So 2 raised to the y power equals x. So if I want to write this log in exponential form, now what happens is, okay, now I'm looking at values of y, right? So as y, as I change values of y, so for a moment, because it's easier to look at this way, so if y is 1, then x is 2. So when x is 2, y is 1, right? So if you want to look at it that way, so when x is 2, y is 1, right? So let's look at bases of 2. Could do it that way too. So let's go when y is 1, x is 2. Okay. Now what about when y is 3, x is 8? So when we go up to here, like let's see here. When y is 0, x is 0, so we have a point here, it's 0, 0. Okay. Oh, and what about when x is negative, well, how do I do that? Negative 1, let's do, when y is negative 1, what does x have to be? So if y is negative 1, that means x has to be 1/2. Okay, and then out at 8, oh, here we go. If y is 2, x is 4. So at 4, y is 2. Okay, so notice what's going on here. So as I get, what if I go to negative 2? Negative 2 is 1/4, right? So if we go to negative 2, that's going to bring me to, so x is going to be 1/4. So as I get to 1/4, I'm going to get to negative 2, right? So now what's happening? Well, it looks like it's doing something like this. Oops. So it looks like as you get closer and closer to 0 in the x direction, right? So as you're getting closer and closer to 0 from the right, y is going to negative infinity. And as you go off to positive infinity in the x direction, you're going off to positive infinity in the y direction. Okay? Let's do this one, 1/4, right? So let's write this again in exponential form. So this is 1/4 to the y equals x. So again, if we look at powers of y, if we look at y, right? So if y is 0, x is 0, so it still goes through, oh, hold on a second. 1, I'm sorry. Hold on, let's go back. I misspoke. When y is 0, x is 1. Right, which is right here. Okay, I plotted the wrong point. Okay, so here, when y is 0, x is 1. So right there. When y is 1, x is 1/4. Hold on a second. When y is 1, so in order for y to be 1, so x is 1/4. I just want to make sure I'm plotting this right. So x is 1/4. Yep, so x is 1/4, right? So when y is 1, x is 1/4. So at 1/4, we're here at 1. When y is what if, okay, so here, if y is -1, then what happens here? This is 4. So at -1, x is 4. So at x equals 4, y is equal to -1. Okay, if we use y equals to -2, that's going to make this equal to what? 16. So that's going to be way out here. But if you notice, it's kind of like doing this. So as we get closer and closer to the y-axis, this is going up like that, getting closer and closer to the y-axis. And then this is going off to infinity. So now the thing is notice how if the base is bigger than 1, we get something that looks like this. If the base is between 0 and 1, we get something that looks like this. In fact, if you notice, it's sort of like an exponential function, sort of like rotated 90 degrees. But in reality, as we'll see, as I've mentioned before, because log functions and exponential functions are inverse functions, these are actually reflections, right, across the so we'll look closer at that. But that's just giving you an idea of what the graphs look like.